Hello. Good afternoon, everybody. I'm gonna do my customary sort of sitting around for a minute and waiting to see that the stream shows up. All right, I see one going, and I see a second going, and I can hear my voice. Excellent. So I did successfully, I don't even want to think about how much time it took, get both Twitch and YouTube set up. So if you have a preference for one platform or the other, you can use either one. And I am trying to monitor two chats at the same time, and we'll see how that goes. And I might end up going back just to YouTube, but for the moment, here we are. Welcome. Today, we are going to be continuing the sort of project we started last time, but we're going to do something a little bit new. So last week, if you were here, we did some data cleaning to get this data set of Kaggler's favorite packages that has information on, loading the data preview, what packages people loaded into their kernels, and then also which packages were loaded in together. So each of these is a kernel, so you can see that there's, quite a few of them. There are, in fact, exactly 4,459. And into this kernel, this first example, somebody imported date time and somebody imported sleep. So what I want to do today is I want to create a network where co-occurrence, so where each package is a node. And if you aren't familiar with networks, I've got some readings here open that might be relevant to us today. Is there like a super basic network in this paper? Where each node is a package. There we go. So here's an example network. These little dots are nodes, and then the little lines between them are called edges. This is just like network graph theory terminology. So in our network, each node is going to be a package, and each edge is going to be the fact that the package is used together with a different package. And then here we have weight, so some of them are thinner and some of them are thicker, and weight is going to be determined by the commonness of co-occurrence, so how often they get used together. And then once we have our network set up, which hopefully isn't going to take an hour, the last time we tried to do network analysis, we were using Python, we were using NetworkX, it was a slog. But this time we're going to be using R and iGraph, which I'm more familiar with, so hopefully it'll go a little bit faster. And we're going to do some community detection. So community detection that's what this paper is about that I brought up. If you have a network and you don't know ahead of time, actually I think this might be a better example. There we go. And you don't know ahead of time which nodes are part of a closer relationship with some other nodes, community detection is the task of looking at this network and being like, oh, there's a community here, these tend to be used together. There's a community here, these tend to be used together. So it's very similar to clustering. It's an unsupervised machine learning sort of task. And the thing that I want to get out of this is for R and Python, what are the sort of communities within the package ecosystem where things tend to be used together? So for instance, I'm imagining that the, the tidyverse, all of the tidyverse packages are likely to be pretty close together. So that's a collection of R packages, including ggplot, magrittr, dplyr, a bunch of different things. So that's what we're doing today. And let's get to coding. I just wanted to give you guys a little bit of background. And because we've already done some data cleaning, I'm actually just going to fork this notebook we did the data cleaning in and then build off of it. And we are going to be using R because that's what I felt like using. And also, I'm really interested in using the gggraph package today, so maybe a little bit of visualization. And I found this kernel that actually Megan wrote 2 years ago, apparently, that has a little example project. So we might build on that a little bit as well. And hopefully the getting it into the network is going to be pretty straightforward, but famous last words and all of that. All right, so here's the data cleaning, and then here's the top 10 that we were looking at. And this is, again, a sample of packages from a sample of kernels. And I don't think I mentioned last time that I removed kernels that only had the default starting text. So when you start a new kernel, you get like a little introduction to what kernels are, and I removed all of those. Okay, and I'm actually going to get rid of these, I think. I'm actually just going to look at the head of this so I can get a sense of what our data structure is. Okay, so right now we have a data frame where we have 2 columns, one of which is the name of the package, the second of which is the kernel ID. And I'm going to start with just the R one because it's smaller, so it'll be a little bit faster to play around with. And then once that's working, we're going to go back and do Python instead. Also, y'all are very quiet today. I hope everyone's feeling okay. No one's been in the chat. Okay. So the thing that I want out of this is I want a data frame with 3 columns where the first column is package A, the second column is package B, and the third column is the number of times that those 2 have co-occurred together. Oh, this would actually be a good interview question. How would you go about doing this very efficiently? And the reason that that's what I want the data structure to be like is because I was looking at this other example that Meg had worked on. And if I look at the data that she uses, it looks like this. So we're creating a network where person A and person B are both nodes. And then the fact that they show up together means that there's an edge between them. And then that final column with the weight is just going to be something that I can add as a little bit of sugar at the end for visualization. So, so I want these to be pairs. I want to look at every package within a kernel and then all possible unique combinations of 2 packages within that. And I don't want to loop. So this, because we're working in R, something in R is that you want to avoid loops pretty much whenever possible. If you can vectorize something, you're going to get significant speed and memory increases, just because of the way the R language works. So I think there's like a combinatorics function that will do that for us. And this is the part that might end up taking significantly longer than I think that it will, but I've got faith. I think we can do this and also do community analysis today. I believe in us. All right, so okay, so first thing I'm going to do is I'm going to group by kernel ID. And that's not going to change anything about the data structure, but it will change the way that we handle things in other functions in this pipe. Kernel ID, okay. And then I want to, so I can actually, it doesn't matter if there's repetition in the data frame. So I could go through and just do for everything that has more than one package, okay, and packages that don't co-occur aren't going to show up, and that's okay. That's not a problem because we're only interested in co-occurrence here. Sorry, I'm thinking of the edge case when there's only one package in a kernel, and in that case, it's just going to not show up in our network. I think actually iGraph can handle that. What we're doing here is we're creating the edges, And if we get a list of all of the unique packages, then those will be all of our nodes. And we can just have an edge that does not, a node that just doesn't have any edges towards it. Sorry, let me make my code a little bit bigger so y'all can see it a little bit clearer. So that's not necessarily a problem that we don't have any edges to a specific node. And I think that's also interesting. Like if you only import one package, what is it? Oh. Okay, what is this combinatorics? All unique combinations are. Unique combination of all elements from 2 or more vectors. That's what I want. All right. I know there's like, I think there's a built-in function to do this. Expand.grid generalizes to any number of input columns. Okay, that's not what I'm interested in because that's going to act over columns, and I'm interested on acting over rows within a group. Okay. Crossing does, okay, but that's still gonna require, okay. So this is taking 2 vectors and turning them into a data frame, and that's not what I want. I want to take a vector and find all the combinations of that vector. Oh, combin. I'm pretty sure this is it. Generate all combinations of the elements of x taken m at a time. If x is a positive integer, blah, 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 blah. Let's see. So can we do combin? Let's try combn. All right. And then the things that we want to do are package. So I think I can just use package here. And then we're going to do them 2 at a time. And then let's just look at the head of whatever that gives us so we don't spit out the whole thing. Yeah, that did not work. What if I tell it specifically that I want that? Error. Length of m equals 1L is not true. Okay. What if I pull this out and I just do this on like the first 3 items in this column? So I'm taking like a little bitty slice. Hi, Carrie. Welcome to the stream. Okay. Yes, this is correct. This is actually doing what we want. Yes. All right. I think I might need to transpose this. So right now it's creating a new row for every 2, and we want a new column. Okay, I can't transpose it. Oh, I can't transpose it. I'm just mad at girls. Okay. All right. What was our thing? Length of m. So m is what we call this argument here, I believe. Yes, number of elements to choose. Equals 1L is not true. I don't know what that means. Let's Google it. Bug tracking system is not true. Unique indexes. Somebody else has gotten this exact error. In addition, data length is not a multiple of split variable. Did I get that warning? I did not. Okay. What if I... You know what? I don't care about this second column with the number of co-occurrences. So I can just select just this package column, I think. That might work. All right, what's this look like? Actually, I'm gonna take just the first couple rows. Let's take the first 10 rows. Oh, okay. Yeah, I do need to group by before I select, because I'm getting, so when I select, I'm picking out just one of the columns. The tidyverse is a lot like SQL. So I'm picking out just one column, but before I get rid of this other column, I want to use it to group. All right, we still get this error. That is a problem. We might have to use a loop here. I would prefer not to, but I think we might be stuck with it. So the reason that I say that is it looks like the problem here is the group by. Oh, it's not the group by. Okay, the group by is not the problem. Because the thing that I'm worried about here, let's just look at the first couple items. And I just want the first couple rows. Sorry, the first couple rows. Rows come before columns. Is I don't want, so if I'm looking at the first 5, I don't want all the possible combinations between them. I only want all the possible combinations between the things that are in the first kernel. Deepu says, your way of solving things from scratch really helped me a lot. Thanks a lot. You're welcome. And on Twitch, Chato says hi. Hello, Chato. This is the part that I naively thought like, oh, we'll bust this out in 10 minutes. We are 15 minutes into the stream. So this is, it's got repetition, which I'm fine with. So we should only be seeing, so like we should never be seeing RSQLite with ggplot2 because they don't occur in the same kernel. But if we look here, we see that ggplot2 occurs with RSQLite. So if we do this, we're going to get actually something that's not usable. It's just going to say every single package occurs with every other single other package, and that's not the case. I don't know what this error means. Okay, let's see if somebody gave an error question to this. I found the question observation number by group, and I couldn't make the roll.sequence answer. If you're looking for efficiency, I suggest the data.table package. Merging. If you're new to R anyway, blah, blah, blah. I don't dislike data.table, but I would prefer to keep things in the tidyverse if possible on this little project. Make your data frames into data.table. Join together based on key columns and sample by group. Someone was actually asking on Twitter if I was going to do an inner join, and I was like, probably not, but maybe yes. Maybe there's a way. Let's see. Common data frame group. Create a list of data frames. Create all combinations of values. Expand is often used in conjunction with left join if you want to convert implicit missing values to explicit missing values. Okay. All possible combinations of VS and cylinder, even those that aren't present in the data. Only combinations that appear in the data. That's not quite what I want. That's a slightly different transformation. I am a shark skin says, hey, what are you trying to compute? So the thing that I want to do is I have this list of packages that occur in specific kernels, and I'm interested in making it so that I have a list of all unique combinations of 2 kernels in the same, of all packages in the same kernel, so that I can create a network diagram of those. And I might just do this the dumb way. You know what? Let's see. Let's take a peek at the head of this. data frame, just so I can get the names right. For I in kernel, oh, right, I need to actually say what the data frame is. I can't just say what the name of the column is. And it is kernel ID. Oh, that's not the right syntax either. Bilingualism. So I am gonna do this, except I'm going to do it where I'm going to create a vector that is true. Oop, except I'm not going to do insertion. So what this should do is this should go through and look for rows where the kernel ID is equal to I, and then create a list of all possible combinations within that. So if we're looking at this little example, it'll be, we're going to start with 1 and it'll say, oh, okay, these 3 rows are the ones where kernel ID is equal to 1, and then it's going to go through and do that combination of all pairs, all unique pairs, and then give it that list. So I'm going to call this new pairs. And I know I'm using loops. I just said using loops was bad, but listen, if this is very slow, then we'll make it fast. Let's make it work first. So let's create an empty data frame, and let's call it packageco cur. Again, I'm starting to look like a Python coder, y'all. I need to keep my R sharp. New pairs, and then I am going to, and this is another thing you shouldn't do, I'm gonna row bind. Binding rows can be very slow, so if you're interested in efficiency and you do have to use a loop, the best thing to do is to create an empty matrix of the desired dimensions to begin with, and then you just sort of fill it in as you go through rather than adding new rows, because that means that things get re-indexed and it can be very slow, and I'm gonna do it anyway. And so I'm going to bind my existing data set. It's going to start out being null and empty, and then I'm going to bind these new pairs that I am making. All right. Let's see what type of error message we get. We get an error message that I am having too many of these. Okay. Error in rbind, number of columns of matrices much matched. So I'm gonna actually give this a, I always forget how to do this, empty data frame dimensions are. I always forget the syntax from this. Just create a data frame of empty vectors. But if you know how many rows you're gonna have in advance, you should just create a data frame with that many rows to start with. This is true. I'm being bad. Here we go. And I want 0 rows, and I want 2 columns. Number of columns of arguments do not match. Okay, so the problem here is that we're gonna have a slight mismatch between packageco occur. What do you look like, packageco occur? That's right, we forgot to transpose. What'd I do? Oh, can I get back to my work? Oops, something is wrong. I think it should probably be fine. I think it's probably that I just unexpectedly disconnected. She said, oh, maybe it's not. I am a shark skin on Twitch says, so if you want all possible combinations, like if 3 packages A, B, C occur in kernel 1, you want something like kernel 1 and then call combinations of A, B, and C. Yep, pretty much. Well, It might have reforked again. So let's go here and see if it is in my work. And if somebody, that's helpful. Somebody noticed if we saw that little error message? Because I think we didn't. I think it should probably be under my work. Fingers crossed. It should be fine. There we go. Okay, excellent. Right, so we were here, and the thing that we forgot to do was transpose this, because when we were playing around with it earlier, it was wide rather than long, and we want it to be long rather than wide. All right. Blah, 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 blah. Error in combin R packages df package R package df kernel blah blah blah, n is less than m. Okay, so n here must be the length of here. Okay, so I'm gonna need to add a little error handling. So remember when I said it's okay if we just don't have packages that never co-occur? That is in fact okay, but we need to test for that first. So let's call this kernel, let's call it current kernel. I think that's more opaque what it is. So this is gonna get the part of our data frame, so the part of the column package that has packages that are in the kernel that we're currently looking at as we go through our loop. And that's actually just much easier to read in general. So I'm going to replace all of this with that. For bam. But we need to check that the length of current kernel is more than 2, because if you're looking for all possible combinations of 2 and I only hand you one thing, you're going to be upset. If you are R, the language. So if current kernel, and it's, I believe it's length spelled all the way out. Yeah, len is Python, is greater than 1. Then this will happen, otherwise it will not. So let's finish up our curly brackets and indent these reasonably. Oops, and it looks like I deleted that, which I shouldn't have. And I'm actually, because this is a much shorter line now, I'm just gonna move the transpose up here and get rid of this pipe. Yep. All right, this should work. It's taking a minute. All right, let's take a peek at this little package co-occur. Does this have the format that we do want? Yeah, that looks good to me. Except there's some repetition, and I don't remember seeing repetition in the top of our data frame. I imagine that it is in this for loop that we have problems, because you can see that we see RSQLite in the second kernel, and I do not see RSQLite in here anywhere. So something's wrong, something's up. Let me get rid of some of these kernels I was just playing around with. Let's just print I and see what it is. I think I might have to go 1 through the length. Oh, I think actually it should be unique. Okay, so what it was doing was, because there are 3 packages in one, it was going through and I'm Sharkskin says, oh, maybe if you nest by group and then do crossing/expand, like map it to the nested data. Yeah, that could work. I think this will also work though, and I do want to do my community analysis. That sounds like it would be quite a bit more efficient than the thing that I'm doing. Oh, so the reason that we got this output was I was just looping through the whole, I don't have it up. I was looping through the whole data frame, and because there were 3 packages in kernel 1, one showed up 1, 2, 3 next to each package, and I was doing 1 3 times because it was looping all the way down. So getting rid of that should also make this slightly faster to run because we don't have quite as much looping. And there we go, reader and SQLite. Excellent, that looks really good. That's exactly what I want. And from here, I'm gonna do a little bit of cleaning up. And first of all, I'm gonna say what this does. Get the edges. I'm Sharkskin says, oh, you're also streaming to YouTube? I'll just head over there, lol. Yep. I'm doing both, and I'm trying to keep on top of both chats, and I think I'm doing okay. Make the edges where an edge is two packages being imported into the same kernel. All right, and again, if I cared a lot, I could go through and tidy this up and make it better, but I don't care that much right now. And it's not a huge data set, so I'm not super duper worried about computational complexity. Okay, now that we have done this, God, it's ugly. Anyway, now that we've done this, step 2 is that we are going to turn it into a graph. And if I remember correctly, we had Megan's example open here. There we go. So we can use her sample code. Show me the code. Okay. And so she's using gggraph, which is the visualization library, and igraph, which is the graphing library, which is one of my favorites. It's more popular in R than it is in Python, I think, but they have R, Python, and I want to say C++. They have a lot of wrappers. And because it is another language wrapper over C code, it's pretty fast. And again, I'm more familiar with it, so I am not going to struggle as much as I would with NetworkX. That was rough. That was real rough. All right, so this thing that we have called packageco occur. Let's do that. So what she's doing in her code is she is reading in from a CSV. We don't have to do that. Kanishka says the letter C. I assume that was some sort of typo. So we're gonna do this part that says graph from data frame, and we're gonna use our data frame that we just made that should have all of the edges that we're interested in it. And I don't think this is going to work necessarily. The title is wrong, so let's just get rid of that. And I don't need to mess with the theme at this point. That's just gonna be like prettiness. Let's see if this works. A lot of things have been masked because igraph calls things reasonable names, and reasonable names are usually taken. And now that we're running this, I'm going to move this all the way up. That was for the igraph thing. Oh, thank you. That was what the function was in. Yes, yes, yes. Thank you. It's available in C. That was very helpful. Thank you. Hey, it's a graph. Ryan says, NetworkX ain't so bad. I updated that fork you were working on a few months ago. Oh, thank you. I don't think NetworkX is bad. I'm just less familiar with it. Oh, this looks like it could be a community down here. These are things that get imported together. And it looks like we don't even have to go through and do the like weighting ourselves. It looks like if I zoom in a little bit, some of these edges are darker than others. Or is that because they're directional? Let's scroll up and actually read the code that we just ran. Oh, okay, no, it's not actually. So what this little argument here is doing is it is making alpha, which in ggplot is the transparency. So is it like very saturated, or can you just kind of see through it? Be equal to the index, so that different rows in different places in the graph get a different amount of transparency, which is why, I'm imagining there's sort of like a, because different points are going to have different indexes, where there's sort of a gradient here. And it does make it easier to see when they're on top of each other, but it is not actually information. Okay, so what I want to do at this point is I'm going to actually take this package co-occur, and I'm gonna get the information on how often things co-occur. And I think I'm trying to Google how to do this. I don't know if tally will do it. Count number of unique rows in R. I don't just need the number of unique rows, I need the number of times each one shows up. Yes, that is exactly what I want. What do you mean this isn't about data analysis? I disagree with this mod. The count function from the plier package will do this. All right, let's give this a little, we'll give this a little try. And let's try it with actually just the head first, just so we can see what that looks like. And I like doing things with just part of the data frame just to see if they'll work first. Well, that did do that. Kanishka says, maybe you can map alpha to the co-occurrence. That was my exact thinks. Or actually I might do thickness, although alpha would work too. Or maybe even both. We can double up on the visualization. So do I need to say what the variables are? It's also, I noticed it's from plier. Plier is actually kind of deprecated. dplier is the current package. But let's see what, actually, let's see if there's a dplier count version that we can use instead. Okay, there's tally, which is a little bit different. Add tally is shorthand for mutate. Count is shorthand for group by plus tally. All right. Count cycle. So, okay. So we are actually, the version that we're using here is actually from dplier rather than plier, because we imported the tidyverse. Kanishka says, I mean both. Yeah. Great minds, great minds. So we're actually going to need to name these columns. I think they're currently called V1 and V2. What was it? Can I just do both? Yes, I can. Excellent. That should work. I should also rename these columns, but I'm not going to. If I were going to make other people use this code, I would. All right, whoop. And then if we look at just the head of package co-occur. Yes, excellent. So we're seeing dplier and ggplot are imported a lot together, but dplier and dplier are only imported together once. I didn't remove duplication if people imported the same package into the same kernel more than once, so somebody did it. It might even have been me, who knows? That's great. dplier and data table not loaded in quite as often as dplier and ggplot too. Interesting. Okay. Yes, I like this. This is good. This is exactly what we want. I'm gonna add it to this. Add co-occurrence counts. And I believe it was called n. So let's get rid of all of these. Flip. Flip. And here alpha is going to be n. And if I look at geom edge fan, what's in there? What other arguments do I have? Mapping, null, position, round, blah, 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 blah. I really just want the aesthetics for it. Show legend. Many geomed layers come in 3 flavors depending on the level of control needed over the drawing. The default no numeric prefix generates a number of points along the edge and draws it as a path. Color equals index. We don't care about directions here because I guess maybe if you import one and then import the second, but I'm not super. Here we go, edge_width. Geometry fan and understand the following aesthetics. Okay, so what I'm going to do is I'm going to copy this, I'm going to put it here, and I'm going to make that equal to n as well. So this should map both the opacity and also the width to the commonness of co-occurrence. And this is probably going to take a minute. Well, it's fuzzy for some reason. It's probably because I'm zoomed out a little bit. I don't see much difference in width unless these are just very big. So let's actually look at the gggraph layouts and see if we can get something that's going to be a little bit easier to read. Graph layout. Show me the examples. All right. So the one that was used in our example was KK. That's the one that's used here as well. This one uses DRL. Data sources. Layouts abound. So here's one that's circular. Here's one that's linear where circle equals true. All right, let's give this a try. That might be cute. And by cute, I mean informative. Okay. Yeah, okay. So we can see that there's definitely, there's some, what would you call these? There's some popular packages, for sure, for sure. Those are the ones that are over here. And there's some that don't have as much co-occurrence, which are around here. But there's a fairly large number of packages that get imported together. It's interesting. All right, what does this one do? Oh, that's right. Tweener is a library. Sorry, this must be really small for you. Tweener is a library that you can use to create animations. That's what I'm looking for. Gem, circle, star, DRL, IGL, grid, randomly, KK. That doesn't look super useful for what we're doing. Hierarchical layers. Okay, so we don't now right now have hierarchical things expressed. Okay, this might work. Let's try this. It's sort of hard to see the relationships, and I do at some point want to also add labels that make it a little bit easier to see what's going on. And multiple parents, unfolding graph, multiple roots in graph, choosing the first, error in vertex attributes, invalid attribute, value length, must match number of vertices. Do we say length anywhere in here? Let's get rid of this aesthetic that tells us what the color is. That might do it. Invalid attribute, value length. Maybe I can make the weight be n instead. No. Okay, well, I don't know how to fix that. Akrof says, hi. Hi. Oh, and Chado says, very cute. I'm assuming you're talking about the visualization. Yeah, it's one of my faves. Oh, you know what the problem is? The problem is that we don't actually have the hierarchical information included yet. How much time do we have left? We have about 20 minutes. I'm trying to think whether it would be more helpful to do something with a hierarchical clustering community detection sort of thing to find out if there's any sort of structure within this co-occurrence graph. Oh, it's so fuzzy. The other option that we would have would be to spend some time making like a nice, pretty, informative graph that tells us more about the data. And I am inclined to do the first rather than the second, partially because I'm really curious about this guy that gets used with like a little set of little packages that also are used together a lot. Yeah, I'm leaning towards spending some time doing a really nice visualization. So yeah, holler if you think that's maybe not the best idea. The other thing that I want to do, and this might be something for another time, is to do some community detection. Kanishka says, wait, are you the same person as the first author of Non-Lexical Features in Code Political Affiliation on Twitter? I am. That is a paper that I am pretty proud of. Yes, okay. Let's make a nice visualization. So the first thing I'm going to do is I'm going to get rid of some of this sparseness and get rid of some low counts. Let's do this up here actually. So let's call this packageco trimmed. I don't want to say pruned because pruning is something that you do to trees, and that would make somebody think that I had done some hierarchical clustering and some like dendritic analysis and then removed part of the tree, and I have not done that. So we're going to take packageco and we're going to filter. Mishka says, I liked it a lot. I'm a first year PhD student doing computational linguistics right now. Oh, cool. Yeah, it's definitely been a good week for computational linguistics because it's empirical methods and natural language processing right now, which is one of the big NLP conferences. And Twitter has been a-buzzing. And I'm a little jealous that I'm not in Brussels right now. But also, I'm not jet lagged out of my mind, so, you know, pros and cons. Lowercase n is greater than 5. And then if we just look at the head of that. Excellent. So these are all larger in the numbers. And I am going to put this up here, right under here, so we still have it later if we want to look back at it. All right. Trim data set of sparse pairs. And then we're going to make another graph. And I'm going to call this graph small. And I'm going to replace all of the places we say graph with graph small. And I think it was just one place. So let's take a look at that and see how that looks. Okay, yeah, that's much better. And for this one, I am going to use KK. I don't know what K means. Oh, right. That was a layout argument. I'm assuming it's like the name of a method that somebody uses. Okay, this is maybe like too sparse. So I'm going to redo this and I'm actually going to say I want things that are greater than 2. Maybe even greater than 1, honestly. Let's see. Yeah, that works. And actually, I'm going to do just opacity, and I think it will still be readable. Let's see. Yeah, I think that's still readable. And it doesn't look quite as fuzzy. I think part of the fuzziness was due to like the numbers, the color, the size. I don't know where I was going with that. The part of the opacity was due to something. And this looks like, I don't know, it doesn't look like there's a very strong like distinction in communities. Like maybe this is one. This is definitely something. There's a lot of interconnection here. Maybe this. Although, I mean, this is a small enough n that this could just be one user. And this is definitely going to have to be bigger for Python. Just because we have a much larger data set. I'm just going to leave myself a little note. So when my enormous graph just crashes my computer, I will know what did it. It wouldn't crash my computer. It would just sort of, the kernel would take a little nap. Kanishka says, I bet the center points are all tidyverse. Oh, that seems likely. Yeah, let's add some labels. GG graph. There are, so there's a label to the plot, but not the graph. GG graph, labeling, ooh, label nodes, that's exactly what I want. Geom node text, annotate nodes with text in GG graph. That is what I want. What does this look like? Okay, can I just say class? No, class is something that is declared up here. So I'm gonna have to say like V1 or something. Because I didn't rename my columns so that they are opaque in the names. Ugh. Object V1 not found. All right. What are you called? I thought for sure it was called V1. Let's take a peek. Yeah, no, it is called V1. All right, so label isn't working. Oh, okay, interesting. Okay. Oh, no. So this is, okay, so this is a class. All right, interesting. So I thought we were just adding a column, but no, this is actually an attribute of the graphed object. And I don't know what this V means. And I don't know what G-order is, but we'll figure it out. Maybe saving it as an iGraph graphed object changes its name. Maybe, but I think what it is I'm trying to take names from the data set, the data frame, rather than doing this thing where we create a name from. So I think this should still stay class. I think this should be V1. I think. Actually, let's comment this out first and then give it a try. Don't know how to automatically pick scale for object of type function, defaulting to continuous, error role which displaying an object, error column label must be a 1D atomic vector or list. All right, so let's try this. Oh, except it should be called graph small instead of GR because that's what it was called. All right, that didn't work. Error in iGraph, in class graphed, object V1 not found. So yeah, this is something, this class is something that is associated with the object. And the reason that I started running this with commenting this out, I was like, oh, maybe it just like whenever you create a graph, class is created as an attribute of it. But I think that may not be the case. So graph underscore small. Oh, this is going to be big. Just show it to me. Show me the whole thing. Okay. Attribute name VC NEN edges. Omitted several edges. Yeah, I imagine so. So can I say that the label is actually the name? Is that a real thing? I can say that the label is the name. That is a real thing. Excellent. Okay. I'm just not super familiar with the structure of this particular type of object. I'm like a little bit familiar. Okay, so we can get rid of that. So this is, I think, taking the first 3 letters of each of the names instead of using the original whole name, but we're gonna ignore that. So this is, I guess, when somebody says library, nothing. And so we see people are only using lattice with LME4. That's still kind of interesting. The center is, never mind, this is Kaggle. The center is machine learning packages. Yep, absolutely. ggplot2, core plot, RE something. XGBoost is in there. dplyr is definitely in there, for sure, for sure. It's interesting because tidyverse is right now one of the defaults that we have in our kernels when you get started, so. All right, can we make these labels more good looking visually to see? Maybe that's what that nicely does. This may not work. Error in circular argument is not interpretable as logical. Okay, if I do this, will that work? Using nicely as default layout. Error in layout. Formal argument algorithm matched by multiple actual algorithms. Meh, whatever. Okay, we can live with that because I want to see what this looks like for Python. So let's do that. We don't have a whole lot of time, but I know there's a lot of Python folks out there, so I don't want y'all to be disappointed. Like, oh, you didn't do Python. And I only started with R because it was smaller. I don't have an anti-Python vendetta. Oh man, I'd love a Python. They're such nice animals. A little Paul Python. That'd be a great pet. Okay, so we're gonna do all this. And let me run this and make sure it works. Is this the point where I should start putting stuff in functions? Maybe. All right, so this is gonna be our initial graph that's gonna be kind of hard to read. And this will be our second graph that'll be much easier to read. And here I'm gonna be bad again. And I'm going to overwrite the things that we made earlier and just change this to pi. And this to pi. And this to pi. And I think that that should be all of the places where we said Python when we meant, in this case, R. So let's run this and see if it works. It's thinking. And it's going to take a minute because this is going to be a big graph. It is a little bit over 10 times as big, the Python data set, as the R data set. So I would not be surprised if that took some while. Label equals name. I want to actually see the node label aesthetics and see if we can't make that a little bit nicer. So what are the aesthetics that it stands? Label, which we specified. That's the text it is, I imagine. Alpha, angle, color, family, font, face, H just, line just, size, and V just. So we can try making the size a little bit lower. That might be nice. What is the default size? I don't know what number to change to make it. Oh my god, that's unreadable. I don't know what number to change to make it easier to read. Hi, hun. I think let's try making it size equals 5. I don't know if 5 is big or small, but I guess we'll find out. Ah, no, dunk. I forgot to do the thing that I left myself a little note to do. Well, beans. I said it was about 3 times bigger, so let's actually go 4 times bigger. Yeah, that's completely unreadable. Is this bigger or smaller? I think it's slightly bigger. So let's actually make size 2 and see if that changes anything. And obviously I've made the N bigger. Okay, yeah, size is changing nothing. This is impossible to read. Let's actually make N 10. And is it not size? Did I misremember what it was called? What's the aesthetic? No, it's size. Interesting. Okay, that's, again, kind of hard to read. I don't know what size is doing. Size is doing nothing. Oh, let's go even bigger. Let's say bigger than 20. Okay, so at this point we can start to see that NumPy and pandas are right in the center here, which is not surprising to me. And we can see Seaborn, matplotlib.pyplot, OS are all sort of in the center. Kanishka says size changes label size, I think. That's what I thought as well, but it's not doing the thing. What if I make it like 0.5? Unexpected numeric constant. Oh, yeah, it's because I deleted the equals points. So that should make it smaller, but I don't think it's a different size. I think it's just adding this like little label here that says size. Which is a little bit unfortunate. Let's see. GG graph labels smaller. Let's see. I want it to be tiny. Text labels are smaller too, making for less crowded plot. That is what I want. Oh, this is base plot. This is like very built in R stuff that's not going to be as helpful. Kanishka says, is it because you're adding it in aesthetic and not outside? I think it should work in, so ggplot is a little bit weird in that all of the aesthetic arguments are done within this aesthetic function. So usually you would say like aesthetic whatever. Geom node point. Geom node label. Aha. Okay, I think what the problem is here is that I am trying to change the label, but I don't know that the label actually knows about this. So geom node point might actually be what knows about size. Let's try that. Does that make it smaller? No. This is well, geom node label size. Weight equals size. Geom node. Let's take a look at that. Label.size does not go below a specific threshold. That does look like what I'm interested in. Kanishka says, oh, I thought aesthetic is usually when you want to vary the aesthetic with the data. Yeah, but I think label size is something that will be... Oh, okay, so it looks like label.size is outside, but also size is in the aesthetic. Because you can hard code things. Like if you want it to be blue, you can, like in the aesthetic, be color equals blue, I believe. Maybe I'm wrong. Maybe that is what the thing is. Let's try this. Let's try putting it outside and see if that helps. Well, okay, that got rid of the black lines around the box. Maybe I should also say something up here. Maybe it's changing like the inside but not the outside. Nope. Okay. Can I just say size? Will it know about that? Aha! Okay, Kanishka, you were right. Thank you for the tip. But instead of that, let's say that it probably is 1 by default. So let's do 0.75. That made it purple. Okay. Okay. Let's make the size like 5. Okay, that's definitely bigger than it was. What about 2? Love to futz around with labels. Okay. Yeah, I think that's visualizable. And down here, BQ and package are imported together. I think that's from a BigQuery thing that we did a while ago, possibly. And score is only ever imported with load. Well, 10 or more times, I think. So those tend to be imported together. Interesting. All right, so I'm actually going to do this up here as well. And it is after 5. So I might call it a day. Beans. It was just, I think we decided on size equals 2, I think. Does that look good and is readable? Oh, well, okay. That's not going to work because I wrote over my same thing that I had used before. Anyway, I'm going to commit this, so there's going to be a version that y'all can play around with if you're interested. I know that last week somebody did a Python version of the stuff that I'd done with R, so that was cool. I always like to see people playing around and trying their hand out. I am not going to be live streaming next week, probably, or at least not on Friday, because I'm going to be traveling for work. But I should be back the week after that, and yeah, maybe we'll get more into this community detection, because I didn't get a whole bunch into that. But it's good. I don't know how much community there is to detect in this data set necessarily. And I wouldn't have known that until I looked at it with my eyes with the visualization. So shrug. All right. Thanks for joining me, guys. I hope you guys had fun. This was enjoyable. I had a lot of fun today. And I will see you not next Friday, but Friday after next for sure. Have a good weekend.